2 years have passed since NASA's James Webb Space Telescope provided us with a stunning first look inside the deepest parts of our universe. This $1 billion telescope serves as the largest and strongest in space. After taking stunning pictures, something was seen through the James Webb Telescope that NASA had been keeping a secret: Mercury. As a result of this discovery, the mission was quickly halted by the United States. This seemingly normal world is far from what it appeared as it orbited close to the blazing Mercury of our enormous sun. The landscape is dotted with unexpected phenomena like sparkling diamonds, but underneath its sparkling surface is a vast and mysterious element that challenges our past scientific understanding of what else is hidden. Truths lie behind these astounding revelations. Let's investigate the discoveries that could significantly change our perspective on the planet. Even though Mercury may appear small, don't let the comparison to the Sun fool you. Beneath its rapidly boiling surface is a wealth of amazing recent, Earth-based probes and secrets. Uncovered a shocking discovery: the surface of Mercury is dotted with diamonds. These extraordinary stones are found on one of our solar system's hottest planets, but this is only the start. When we delve deeper, we discover that Mercury's core is extraordinary and bizarre all at once. These findings raise significant inquiries into what distinguishes Mercury from nearby planets and what else it could be. The spacecraft Mariner 10 was the first to reach Mercury, making it an early adopter of space exploration. It brought back the initial close-up pictures, showing a planet with strange features, craters, and ridges similar to those on our moon. This mission shattered preconceived notions regarding Mercury's makeup, demonstrating a rough surface that surprises with a core with a powerful magnetic field larger than previously thought. But the most shocking revelation was not this one. After 3 decades, the Messenger mission changed our lives forever. Unlike Mariner 10, the mission of Messenger was to orbit Mercury, enabling comprehensive, long-term observations. It recorded nearly 200,000 images, substantially expanding our knowledge about the world and finding Mercury's previously unseen regions. Messenger's most significant finding was the discovery of remarkably high levels of both calcium and magnesium. This sparked fascination with Mercury's darker side, the natural processes that could be responsible for the raised levels of these elements. It surprised scientists to learn that, unlike other solar system planets, Mercury's magnetic field was remarkably stronger in its northern hemisphere. These results made scientists reconsider their past presumptions regarding the interior of Mercury and its Earth-wide geological development. Molten iron moving within the core is primarily accountable for producing magnetic fields, but Mercury demonstrates a distinct type of magnetic activity as a result of its unique internal structure. What else distinguishes Mercury? The planet's craters and ridges surface encounters severe weather. Temperatures can soar to a scalding 800 degrees during the day, high enough to melt lead, but the temperature drops at night to around 290 degrees. Mercury's thin atmosphere does little to regulate or retain heat, causing dramatic changes in temperature. But there's more to Mercury's extreme heat. Recent examinations from the 2012 Messenger mission revealed historical evidence of explosive eruptions and evidence of ongoing eruptions. This shook up the previous theory that Mercury had been geologically inactive for 1 billion years. Then, in 2020, researchers developed yet another fascinating discovery. Parts of Mercury's polar regions, permanently obscured, contain water ice. Despite Mercury's close proximity to the Sun, these regions remain sufficiently frigid to preserve frozen water as a result of their protection. This discovery brought about fresh questions regarding whether Mercury could support prehistoric organisms in these frozen regions, similar to the most inhospitable environments. This question has interesting repercussions for our comprehension of life's potential to thrive, particularly on other planets in settings that might appear hostile. To us, the narrative continues. In 2018, in partnership with the Japan Agency for Space Exploration, the ESA launched the Bepi Colombo spacecraft, heading toward Mercury, expected to arrive by 2025. Bepi Colombo will begin collecting extensive information about Mercury, including the composition of its surface and geological history. Despite Mercury's proximity to the Sun, water ice, and a powerful magnetic field, what might even more astonish you is that a day on Mercury is actually longer than its year. When we consider a planet, we normally envision it orbiting the Sun once a year and rotating on its axis once daily, but Mercury defies this expectation. A day on Mercury, or a complete axis rotation, requires approximately 176 Earth days, while its orbit around the Sun takes only 88 Earth days. This means that Mercury's year lasts half as long as a day. Some peculiar events were observed. The Sun rises slowly on Mercury, expands across the sky, but then appears to halt, retrace its steps, and then carry on with its journey. This is due to Mercury's sluggish rotation in relation to its quick circling of the Sun. Why does Mercury rotate so slowly? The answer lies in the locking of tidal waves billions of years ago. The Sun's pull on Mercury has progressively slowed its rotation. Mercury orbits with a 3.2 spin-orbit resonance, which indicates that it completes 3 turns about its axis for every 2 orbits around the Sun, resulting in a unique daytime cycle that contributes to extreme variations in temperature on the planet. With the Sun on one side, temperatures can be scorching, while long stretches of icy darkness persist on the opposite side. These changes in temperature are among the most extreme in the solar system as we know it. It's important to keep in mind that Mercury does not have a typical atmosphere similar to Earth's. Instead, its exosphere is extremely thin, so infrequent that it disappears into space, never to be found again, occasionally influenced by the radiation of the solar wind and small space debris collisions. Recent studies have shown unexpected information regarding Mercury's exosphere. In 2020, Messenger spacecraft data demonstrated that scientists had underestimated the volume of Mercury's water vapor. This water vapor probably forms in the exosphere when oxygen in Mercury's rocks interacts with solar-generated hydrogen wind. Yet another amazing feature is the speed at which Mercury revolves around the Sun, particularly in comparison to its strangely slow rotation about its axis. This combination significantly affects the magnetic properties of the planet. The discovery shocked scientists that Mercury possesses a powerful magnetic field despite its relatively small size and slow rotation. Additional research indicated that Mercury's distinct rotation and orbit, along with specialized movements within its core of liquid metal, influence the planet's magnetic field. However, it's important to remember that Mercury's magnetic field is weaker than Earth's surface, shielded from the ferocious solar wind. Without this shield, the solar wind would make Mercury's already sparse exosphere even thinner. The fascinating combination of spin and rapid orbit creates unique conditions on the surface of the planet. For instance, Mercury has regions known as hot poles, where the Sun appears to float in the sky for a significant amount of time, generating excessive heat. On the other hand, areas near Mercury's poles remain in constant darkness, kept cold enough to allow ice to persist despite the planet's proximity to the Sun. Mercury's rapid orbit and slow rotation pose obstacles to space exploration, as spacecraft must use intricate methods of navigation. The 2018 Colombo mission was launched, including numerous Venus flybys and Mercury flybys, to slow down sufficiently to enter the planet's orbit. Currently making use of these flybys to alter its speed and trajectory once it arrives in 2025. Colombo's spacecraft will require careful control of its power and temperature systems to withstand Mercury's peculiar day-night cycle. This cycle continues to astonish scientists by providing new hints about the planet's development and how it came to be. According to planetary research, Mercury may have started out spinning faster before slowing down gradually as a result of the Sun's gravitational pull and impacts from other planets and stars. This discovery provides additional information about Mercury's history and the forces that, as scientists continue to investigate, shape the evolution of the planet. New inquiries arise about the surface of Mercury, its core, and the distinctive forces that have shaped it. The more we learn, the more we understand how Mercury poses a great challenge to our understanding of planetary science. Mercury remains the smallest planet in our solar system, yet it contains many mysteries that continue to captivate scientists. One of the most remarkable features is Mercury's enormous core. According to planetary scientist Dr. Nancy Szabo, Mercury's core is approximately 85% of the planet's volume, but only 15% of its total mass. This raises a crucial inquiry into why Mercury's core is so large. According to one popular theory, referred to as the large-scale impact hypothesis, Mercury used to be much bigger, but lost much of its outer layers as a result of a massive collision early in the solar system's history. This theory suggests that a massive object slammed into Mercury, removing its outermost layers and leaving the dense, iron-rich material of Mercury's core that we see today. Despite its small size and slow rotation, scientists were surprised to learn that Mercury has a global magnetic field, in contrast to Venus and Mars. This discovery, made by NASA's Messenger spacecraft, contributed to additional studies. Researchers, including Dr. Katherine Johnson and her team, discovered that Mercury's magnetic field is uneven, displaced by approximately 20% of the planet's diameter, which may be related to changes in the planet's crust and the method by which heat escapes from its core. In 2020, additional research revealed that volatile materials, such as sodium, potassium, and sulfur, are present on Mercury's surface. These findings contribute to the expanding body of knowledge about Mercury, making it one of the most exciting planets in our solar system. As we continue our investigation, Mercury's mysteries are still being solved, redefining our perception of planetary formation and evolution. Mercury-related mysteries continue to entice scientists and researchers to explore its many enigmas. While some discoveries provide insights, others remain unanswered. One of Mercury's most fascinating features is the presence of volatile compounds at high temperatures that would typically vaporize. Dr. Patrick Poplawski from the Johns Hopkins Applied Physics Laboratory has argued that these materials could have been delivered by comets or asteroids long after Mercury's formation. One of the most exciting revelations is the presence of water ice in shadowed craters at Mercury's poles, made possible by Dr. Nancy Szabo's efforts. This ice remains frozen in craters due to their extreme cold and the potential for complex carbon atoms similar to those that may have given rise to life on Earth. This adds an additional layer of intrigue, as Mercury's extreme conditions provide clues regarding the potential for life in our solar system. Mercury's geology has been more surprising than previously thought. Although once considered geologically dead for billions of years, data gathered by NASA's Messenger spacecraft shows recent volcanic activity. Dr. David Rothery from the Open University in the UK discovered small hollows, which are shiny volcanic vents that provide information about the planet's ongoing geological processes. These slits in a portion of the planet's surface indicate that Mercury's geology could still be developing. Mercury's chaotic terrain is another peculiar aspect. A vast, chaotic area close to the southern pole was first discovered during Dr. Thomas Waters' 1970 Mariner 10 mission. The Smithsonian Institution suggests that massive Earth-like tremors brought on by Qianshang system by the sun's gravitational pull may have shaped this landscape. The internal structure of Mercury is equally fascinating. Utilizing data from the Messenger mission, Dr. Amir Khan of the University of Zurich discovered that Mercury has a massive solid inner core surrounded by a liquid core, much like Earth's, but Mercury's inner core is significantly larger, which may explain its unique magnetic characteristics. This unexpected information challenges our comprehension of planetary formation and evolution, demonstrating that the solar system is full of secrets. Additionally, the Messenger mission discovered that Mercury's mantle is only 260 to 420 kilometers thick, much thinner than Earth's mantle. This thin mantle influences the planet's heat distribution and geological activity. Researchers found ancient volcanic artifacts beneath Mercury's surface, including superficial depressions known as hollows, formed when volatile compounds evaporated near the surface. In 2020, scientists discovered evidence of a magma reservoir that once formed large, flat volcanic plains, particularly in the northern hemisphere. These volcanic plains were likely formed by massive lava flows early in Mercury's history. In 2022, an analysis of messenger data revealed additional mysteries, including hints of nitrogen held in place below the surface. This suggests Mercury might have had a denser environment driven underground by the planet's intense heat and unrelenting solar radiation. The discovery of ice in permanently shadowed craters at Mercury's poles, sheltered from the sun, is particularly fascinating. This ice, possibly relatively young and delivered by comets or asteroids over the past tens of millions of years, may contain organic compounds, raising intriguing questions about the possibility of life or its precursors on Mercury.